Hello everyone, welcome to Swift Dynamics. I hope everybody is safe and doing well. Today we are looking at a question called first bad version, which is asked by Facebook in coding challenges. You have given a n set of releases of a product and you have to find out the first bad version from that list. So the n releases means 1 to n. So if the n value is 4, that means you have releases from 1, 2, 3, 4, and you have to find out the first bad version. To find out the bad version, you can use the given method, which is bad version. So one way is to solve this problem is to go from 1 to n in a linear way, so that we will search 1, then 2, then 3. And the problem with that solution is it goes n times, and it touches all the elements, which can be avoided here by using something called binary search. So the idea is to search the mid element and find out whether that's a bad version or not. If it is a bad version, then we know that the first bad version will be either the mid or it will be on the left side of the mid. So we can update the right value, and then if it is not bad version, that means that we know that the bad version will be on the right side, so that we can update the left value. So let's get into the code. We will define two values. One is left, which is 0, and then right, which is on the end, which will be n. So then while left less than right, then we will find the mid value, which is mid. Left plus right minus left. This method is to avoid the overflow of the mid element, and then search whether the mid value is a bad version or not. That can be done using this bad version method. If it is a bad version, that means either the first bad version is that mid or it is on the left of mid. So we change the right value to mid, else we will change the left value to mid plus 1, because it will be on the next one. So, and then return left, and let's submit that. Okay, that's it guys. If you guys like the content, please make sure you click on the like button and don't forget to subscribe to my channel. Thanks again.